Hello guys, welcome to this session. In this session, we will discuss about tokens in C++. So consider this program. In this code, each line gives an instruction to a compiler. Each line is a combination of words. These words are separated by a blank space. A blank space means white space. So each word should have a meaning that can be understandable by the compiler. In C++, these words are said to be tokens. So program is a combination of tokens. So tokens are a smallest individual unit of a program. So we can classify our tokens into 6 different categories. Keywords, identifiers, constant, string, operators, and punctuators. So first let us see what is keyword. So keywords are the special words, or we will say it as a reserved words. These reserved words will have a special meaning that is understandable by the compiler to do some specific operations. So here we had given a few keywords: int, float, char, if, else. So in this keyword, it has some special meaning. Consider int. It allocates 2 bytes of memory for a variable. Float. It allocates 4 bytes of memory. So char, it allocates 1 byte of memory. If, it checks for a condition. Else, if the condition fails, a false block has to be executed. Switch. So it is a multiple condition checking statement. So each word has a meaning which is known by the compiler. So this words we cannot be used as a name of an identifier. So it has some special meaning. We just going to make use of that. So next let us see about identifiers. Identifiers are the name of a variable or function or array or class. So we are going to name the variables. So for naming the variables, we have to follow some rules. So for naming, we have to use only character, number, underscore for naming the variable. The name should not start with digit. So it can start with underscore or an alphabetic character. So the uppercase and lowercase letters are distinct. Consider in this example, score in lowercase letter and in uppercase letter are 2 different types of variables here. Then keywords, that has a special meaning. We cannot use this keywords for the name of a variable. So int, main, catch, all this are false statements. So here in this example, int number 1. Int is a keyword. Number 1 is a name of a variable. So now you know 2 types of tokens. One is keyword and another one is identifier. Next, we have to see what are the values we are going to assign for an identifier, that is constant. So constant refers to a fixed value that do not change during the execution of a program. There are 2 types of constants we use in our program. One is literal constant and another one is symbolic constant. Literal constant are some fixed value used in the program. So consider this example, int x equal to 4. Here we are assigning an integer constant, some constant to a variable. So this variable of type integer. So we can have integer constant, float constant, character constant, string constant, boolean constant in our program. So simply the values assigned to a variables is said to be a literals. That remains same during the execution of a program. So after a few lines we had given x equal to x plus 2. Now we are adding 4 plus 2. Now the value will be 6 is stored in x. So what happens internally is, so x will hold a value 4 initially. So it will not hold the value, but it holds the memory location where the value 4 is stored. So 4 is stored in some memory location. This memory location value is address is stored in a variable. So variable will hold the memory location, not the value, not the constant. So when you increment the value of x, now the x will have a value 6. So this 6 will be stored in some locations. So for example 1, 2, 2, 3. This 1, 2, 2, 3 location will be, address will be stored in x. But the location 1, 1, 2, 4 remains same. The value of 4 remains same till our program completes its execution. Only the variable which refers to the value has changed its memory address. Now you will be clear what is this constant, how the values remain constant during the execution of a program. Now let us see what is this symbolic constant. In some condition, the value of a variable should be fixed. Consider an example, the pi value in mathematics, that should be 3.14. The sine value, cos value, that should not be altered during the execution of a program. So this can be implemented by using a keyword constant. So this keyword is used to make a variable to refer a fixed value. So this can be declared by two methods. One is by using a keyword constant and another by using a enum. So for using a keyword constant, we can declare by two ways. One is by giving constant at the beginning of a declaration or after a data type. So most preferably we will use the first type. Keyword should be at the front of a declaration. So when you give constant here, this pi value is unaltered. So the next method is enum. So enum is used to define a set of values. So n1 will have 5, n2 will have 10. So these values are not changed. N1 cannot be changed during the execution. So by using enum, only an integer values can be assigned as constant for a variable. So this is how we are going to make a variable to refer to a fixed constant. So now next we will move on to strings. Here in C++ we had some special operations on the strings. That is, we can concatenate two strings, we can find the length of the string, we can remove a part of the string. So all these operations are already built in. It can be used in our program by including header file string.h. So here the string means a combination of characters, a sequence of characters given in a double quotes. So the next one is operators. So operators is a symbol that tells the compiler to perform some specific operations, that is mathematical operations or logical operations. So in C++ there are different types of operators. So plus, minus, that is addition, subtraction, multiplication, division, all these are operators. So we can classify these operators into three different categories. So first let us see what is the first category, unary operator. What is this unary operator means? It operates on only one variable. Okay. So increment and decrement operator. So this increment and decrement operator, what it does is I plus plus. It increments the value of I and it stores the value in I itself. I minus minus. It decreases the value and stores in I itself. So unary operators are the operators which operates on a single variable. Here in this example, I equal to 5, the first statement. Next statement is I plus plus. Now we are going to increment the value and store it in a I variable. Now the value increments the value by 1. I plus plus means increments the value by 1 and stores in I. Now the I value will be 6. I minus minus, it decrements one value and it stores in I. Now 6 is the value. When you decrement 1, it is 5. It is stored in I. So this is unary operator. Unary operator operates on a single variable. Next is binary operator. Binary operator operates on a two different variable. First, let us see what is assignment operator. Assignment means we are going to assigning a values to a variable. That is a equal to 5. We are going to assign a value 5 to this variable. This is assignment operator equal to. So what is this plus equal to? We are going to add a value and going to store it in a same variable. Now a value a is incremented and stored in the variable a. Next, a is subtracted from b and the result is stored in b. See, if it is the value is 5, a and b is subtracted. 10 minus 5, the value is 5. It is stored in the variable a. A multiplication b, that is a is multiplied with the variable b and the result is stored in a. Here, reminder. A is value 25, b is 5. When you get a reminder, the reminder is nothing. It is everything is divisible by 5. So it is 0. So this is assignment operator. We are going to assign some values to a variable. The next is arithmetic operator. So this arithmetic operation is addition, subtraction, multiplication, division and remainder, that is mod function. So here it operates on a two variables and we are going to assign it using a assignment operator in another variable. So the next is relational operator. The relational operator is we are going to compare the two variables. So for that we will use this relational operator. So consider this example, a less than b. It compares two variables a and b and it provides the result true or false, that is 1 or 0. If the condition is true, it returns 1. If the condition is false, it returns 0. So here a equal to 5, b equal to 10. A is less than b. Yes, it is less than b. So it returns a value 1. A is greater than b. No, it is not. So it returns a value 0. A is less than equal to b. Yes. Here we are checking two conditions, less than or equal to. Any one is satisfied, it should return a value true. So here also there are two conditions, greater than or equal to. If one is satisfied, it returns true. But both the conditions are failed. It is not greater than b and it is not equal to b. So it is less than b. So it is false. So another is equal to. Checking, we are checking equal to. A is equal to b. Another one is not equal to. Not equal to means if a is not equal to b, it returns yes, a is not equal to b here. So it returns the value true. So Now you know what is this relational operator. This relational operator compares two variables. Next is logical operator. Logical operator, here it is same as a relational operator, but it returns the logical operator is same as that of a relational operator in return values, true or false. But here it compares two conditions, okay, two expressions. A less than B is one condition and B less than C is another condition. We are going to compare the two conditions. This is AND operator, this is OR operator, and it is NOT operator. What is AND means? When the both the conditions, when this condition A less than B and B less than C is true, it returns the value true. If both the condition is true, it returns the value true. If one is failed, it returns a value 0. So here it is opposite. If any one is true, it returns a value true. If one is, if both is false, it returns a value false. So here it's an example: A equal to 5, B equal to 10, C equal to 15. We are comparing A less than B and B less than C. Yes, this is B is greater than A and B is less than C. Yes, this both the conditions, here it is 1, here it is 1. So AND operation is 1 and 1, it returns a value true. If both the conditions are true, it returns value 1 in AND. If any one fails, it returns false. So, but in OR operation, if any one is true, it returns a value true. If both are false, it returns a value false. This is NOT. It reverses. If it is true, this expression is true, it returns false. If this expression is false, it returns true. So this is the purpose of NOT. We are going to reverse the value. So this is the purpose of logical operator. We are going to check both the conditions. So next is bitwise operator. It operates on the bits. Here in this example, A equal to 5 and B equal to 10. We are making AND operation for A and B. AND means when both the value has 1, it returns a value 1. Or otherwise, for all the condition, it returns 0. So now the C value is 0. When you make OR operation for A and B, if either one is 1, it makes 1. If both the conditions are 0 only, it makes it as 0. So now it returns a value 15 to C. When you make a shift operator, shift one position to its left. So what happens? It adds 1 0 to the last. It's one position. So adds one digit. So now the value is 10. When it right shift, it again makes 0 this side. Now this value is 10. A value is 101. When it shifts, its value is 10. It is stored in the variable C. This is exclusive OR. Here, if both the values are different, it returns a value 1. If both are same, it returns a value 0. So consider an example here: 1 0, it returns 1. 0 1, it returns 1. 1 0, it returns 1. 0 1, it returns 1. So now all the values are 1. The value is 15. So now you know what is exclusive OR. Exclusive OR returns a high value when any one is high. not the both. So next is not of A. It reverses the A value. This is bitwise operator. It operates on a binary values. So these are the operators in binary operate. So these are the operations to be performed on the binary operator. So next is ternary operator. Ternary operator means we are going to operate on the three variables. That is x equal to a question mark b colon c. What this is, a is a condition. If the condition is true, it stores b value to x. If it fails, it stores c value to x. So here we are making condition x equal to a. That is a is a condition. If a is true, it stores a value b to x, or it stores a value c to x. Here is an example. A will have some value. If the some value greater than 5, if it is true, it stores x to be 5, or it stores a value to x. So this is ternary operator. So these are the operators in C++. Now we know what are the different types of tokens used in the C++ program. So I hope this video might be helpful. Let us meet in another session. Bye guys.